Do you know that in Oaxaca, thousands of families lose their homes every time an earthquake strikes? And that there is a way to rebuild in weeks what used to take months? And the question is, how is this possible? Right. The modular construction is a building method in which a complete section of a structure are manufactured in a plant and later assembled on site. And this is amazing because this reduces time, cost, and ensure better quality control. But emergent technologies like a DFMA, designed for manufacturing and assembly, are transforming the constructions. For another hand, DFMA impact in engineering process by reducing execution times. Models can be assembled in weeks instead of months. Other benefit of this technology is the improving logistics because the models are designed for quick transportation and installation. And using materials more efficiently, less waste, and more sustainability. Other really important point is increased productivity because the plants can be delivered housing lots more quickly in case of the natural disasters. For example, in a simulate of 30 model homes, with the technology DFMA, we can complete the cycle in 3 months, compared to the 9 months of traditional construction. But now, what is the problematic? The problematic is that Oaxaca is a region in Mexico with high seismic activity, leaving communities vulnerable. Now, for this point, in applied knowledge, I'm going to compare the traditional construction with the modular construction, DFMA. To demonstrate that investing in a modular construction with DFMA is more cost-effective than the traditional method, I conducted an economic analysis using the CAWE. I compared two alternatives. Traditional construction with an initial investment of 1.2 million pesos and an annual operating cost of 215,000 pesos. And the modular construction with DFMA with a higher initial investment of 1.2 million pesos but much lower operating cost, 120,000 pesos per year. Using a 12% interest rate and a 10 years lifespan, I calculate the CAWE for both options. And for break-even point, beyond the CAWE comparison, I also calculate the break-even point. The result shows that after 80 models, the FMA become more cost-effective than the traditional construction. In small projects, the traditional may seem cheaper, but once we reach that scale, the FMA clearly outperforms because of its lower operating cost. We can adapt this technology in different companies. For example, Toyota, Siemens. We can apply this technology in manufacturing, construction, or different sectors. And some predictions say that the modular construction can grow in more than the 6% for the 2032. The technology integrate with automation, 3D printing, and the sustainable materials. In my critical thinking, the DFMA faces challenges. Other point is the investment because this requires advanced infrastructure and specialized training. And finally, I think that the regulations, because the local codes may delay the adoptions of this technology in Mexico. In conclusion, I think that the technology is viable, but needs a strategic planning to adapt. For my self-evaluation, I still that I need to study more my knowledge in production flow simulation and modular construction. I will continue learning more about the specialties in software and practical projects. This project helped me to straighten different points For example, the economic analysis skills. I can understand how can I apply the CapCut, for example, and break even in a case. And someone is the research and autonomous learning skills, because you need to search all the information that you don't know anything. For the future, in the medium term, I will be to participate in projects integrating the DFMA technology with the productivity and sustainability. And in the future, I will to apply the DFMA to optimize investment and projects management decisions, reducing cost, time, the risk, and leading in initiative to promote the resilience and the sustainability in the construction. And for break-even point, beyond the CapCut comparison, I also calculate the break-even point. The result shows that after 80 models, the FMA become more cost-effective than the traditional construction. In small projects, the traditional may seem cheaper, but once we reach that scale, DFMA clearly outperforms because of its lower operating cost.